Hi friends, welcome to the channel. This channel is intended for those home brewers who are making new transceivers. For a new homes, it is not possible to purchase high cost transceivers because it is very huge, very high value. I am introducing many type of transceivers and how to build it and how to operate it. For making a good transceiver, an oscillator is essential. Earlier, earlier days, LC type local oscillators are used, but it is varying frequency with the time. I am introducing the DDS VFO. DDS VFO replacing the old LC oscillator with a constant frequency output. These are the various types of DDS VFO I make and I used it in several transceivers. I am introducing the various parts of a DDS VFO and how to assemble it, where we can get it is the availability of the parts, and we can use blue, green and any type of LCD screen on it, and it is using Arduino Nano, PIC IC and some clock generator ICs. For making DDS VFO, we are using many type of signal generator module just as AD9850, SI5351, SI570, AD9851, etc. etc. But among these, AD9850 and AD9851 gives only single output, but it is sine wave. SI5351 produces three output, clock 0, clock 1 and clock 2. But all these three output are square waves. One output, clock 0, is using for variable frequency oscillator, and other output, clock 2, is for beat frequency oscillator. That's why most of the circuit and homebrewers are interesting to use SI5351 based DDS VFO. Now we can see the various parts of a DDS VFO. This is a DDS VFO PCB. It is getting from VU to VET Sudhindra Raja from Bangalore. It is very nice and double-sided PCB with good quality. You can order from VU to VET Sudhindra. I will give the details. This is the Arduino Nano, which is the heart of this DDS VFO. We are programming the Arduino code on this Arduino. This is the SI5351 signal generator. This is a 10-pin MSOP package. This is the DDS module and SI53 module, also known as, and it is giving a separate breakout board. This is the rotary encoder which we are using for changing the VFO frequency. By rotating, the frequency varies. 3.3 volt regulator using for the SI5351. And all the circuits are powered with 7805, that gives 5 volt constant output. This is the display, 16:2 display. I will explain it later, very detailed. And many type of connectors are using. This is the Berg connector which we are using for the Arduino Nano and for connecting to the display also. And two number of BS170 MOSFETs are using for down converters. One power LED for detecting the presence of the voltage on the board, and two diodes for the reverse protection, and some resistors, capacitors, etc. we require. This type of 10 number MLC capacitors I am using. Any type of disk capacitor with the same value you can use. This is the 10K preset potentiometer for adjusting the contrast of the LCD display. Some resistors we require 10K value, and 100 ohm value is using for controlling the brightness of the LCD display. 4 number of 100 microfarad capacitors required. 100 ohm resistor for LCD backlight. some wire also required. You can connect it any wire, any type of wire you can use. And we are testing the LCD display. Only 3 connections are required for testing an LCD display. The first pin is ground, the second pin goes to the positive 5 volt, and the third pin goes to the potentiometer, which controls the LCD contrast. Now, by adjusting the potentiometer, we can see 16 number of square on the display, but it is very dark. We are not able to see clearly. By giving the supply to the LED backlight, we can see it very clearly. The last 2 pins, that is the 16th and 15th pins, are going to the LCD backlight. 15th pin is negative and 16th pin is positive. After connecting this, we can get the backlight, and then adjusting the potentiometer, we can see the 16 number square on the top layer of the display. These are the various type of displays available in the market. It is 20 by 4, 16 by 4, 16 by 2. We can see the detailed connection of a 16 by 2 display. 16 by 2 display means there are 2 layers, the upper and the lower. It is having 16 digit in the upper and 16 digit in the lower. We can see the connection diagram. It is having 16 pins. The first pin is called ground pin. It is always connected to the ground. The second pin is positive 5 volt. Remember that, not give more than 5 volt. The third pin, we can adjust the contrast of the display. We can adjust the brightness of the square or the digit seeing on the display. The fourth one is register reset. The fifth one pin is called read or write. We can read or write from the display. Mostly always we are connecting this fifth pin to the ground. Sixth pin is called enable. From pin number 7 to pin number 14, it is called data pin. We are giving 8-bit data to the display. But normally data pin 7 to data pin 10, that is 4 number D0, D1, D2, D3 are not connecting or connecting to the ground. And then D4, D5, D6, D7 are connecting to the circuit which we are using. These are called the data input of 4 wire. The 16th and 15th pins are for the LCD backlight. It is 15th pin is for positive 5 volt and 16th pin is ground. The next video I am explaining how to load a program to the Arduino Nano. Detailed link are given in the description box. Thanks for watching. Please like, share and comment. Bye bye.